Hello students, this is R. Kisama from IIT Sure. We are going to study question number 3.9 from Irodov. A thin wire ring of radius R carries a charge Q. Find the magnitude of electric field strength on the axis of the ring at distance L from its center. Investigate the obtained function at L is greater than R. Find the maximum strength magnitude and the corresponding distance L. Also draw the graph of E versus L. So this is a ring which carries charge Q and its radius is R. So charge per unit length will be Q divided by 2 pi R, and this is the point where electric field is to be found. This is at distance L from the center, and we consider two current elements DL diametrically opposite. So due to this current element, electric field will be in this direction, whose components will be d cos theta in this direction and d sin theta will be along this direction. Similarly, due to this current element, the electric field will be in this direction and its components will be d sin theta upward and d cos theta in this direction. So here it is clear that d sin theta components will cancel out and d cos theta components will get added up. Now d will be given by dq divided by 4 pi epsilon naught s square. So we put the value of dq, that is q dl divided by 2 pi r times 1 upon 4 pi epsilon s square. Then we find d cos theta. So we put the value of cos theta as L upon S base upon hypotenuse. So d cos theta will be q dl into L divided by S whole divided by 2 pi r times 4 pi epsilon naught S square. So we find total field due to the charge ring, that is we integrate it from 0 to 2 pi r d cos theta. So that is 0 to 2 pi r ql dl divided by 2 pi r 4 pi epsilon naught S cube, which is equal to ql 2 pi r 4 pi epsilon naught S cube, and integration of dl will give L, and we put the limit 0 to 2 pi r, so that will give 2 pi r. So 2 pi r will cancel out and we will be left with ql divided by 4 pi epsilon naught S cube. Now we can say that E equal to ql divided by 4 pi epsilon naught within bracket S equal to r square plus L square and then whole power 3 by 2. If L is greater than R, then E will be QL divided by 4 pi epsilon naught into L cube. 1 L will cancel out and we will be left with Q divided by 4 pi epsilon naught L square. Now in order to find maximum value of E, we differentiate it with respect to L and then we put it equal to 0. So d by dl will be equal to Q upon 4 pi epsilon naught. Then we apply the formula of quotient rule. So we write denominator into differentiation of numerator minus numerator into differentiation of denominator divided by denominator square. Then we equate it equal to 0. So we get L equal to plus minus R by root 2. So we put this value of L as R by root 2 in E equal to QL divided by 4 pi epsilon naught R square plus L square whole power 3 by 2. So after putting value, we get E maximum equal to Q times R by root 2 divided by 4 pi epsilon naught R square plus here we write the value of R as L as R upon root 2. So that will become L square divided by 2 whole power 3 by 2. Here 2 is missing. So on simplifying, we will get E max equal to Q divided by 6 root 3 epsilon naught times R square. Now we plot the graph of E versus L. So E equal to, we have QL divided by 4 pi epsilon naught R square plus L square whole power 3 by 2. So its graph will be like this. Here we have obtained that E maximum will be found at L equal to R by root 2. So which is shown here. So here this value is L equal to R by root 2. Here E has maximum value, and in this direction also, when L equal to minus R by root 2, we are getting maximum value of E. Hence the answer. Thank you.